Hello everyone, we will study about Diffie-Hellman today. Let's see techniques for encryption first. There are two basic techniques for encryption: symmetric encryption and asymmetric encryption. Symmetric encryption is also called secret key encryption, and asymmetric encryption also called as public and private key encryption. So there are number of parties involved and number of locks and key repairs. If number of parties is 2, we need 2 into 2 minus 1 upon 2 is equals to 1 lock and key repair. If number of parties is 3, then we need 3 into 3 minus 1 upon 2 is equals to, we get 3 lock, key and repair. So the formula for this is n into n minus 1 upon 2. History of Diffie-Hellman. The Diffie-Hellman algorithm was developed by Whitfield Daffy and Martin Hellman in 1976. This algorithm was devices not to encrypt the data but to generate some private cryptographic key at both ends so that there is no need to transfer this key from one communication end to another. Diffie-Hellman algorithm. Asymmetric encryption of data requires transfer of cryptographic private key. The most challenging part in this type of encryption is the transfer of the encryption key from sender to receiver without anyone intercepting this key in between. The transfer, or rather generation on same cryptographic keys at both sides secretively, was made possible by the Diffie-Hellman algorithm. Definition: Diffie-Hellman algorithm is an algorithm that allows two parties to get the shared secret key using the communication channel, which is not protected from the interception but is protected from modification. Here is Alice and Bob, and in between Eve. The first step in public key cryptography: Alice and Bob want exchange an encryption key over an insecure communication link where Eve is listening. To do this, they need to use a prime number. The Diffie-Hellman algorithm uses a simple concept in mathematics where a prime number can be used to generate a list of numbers in a seemingly random sequence. This seemingly random sequence is what makes the algorithm secure. Step 1 is Alice and Bob agree on a prime number p. So here p is equals to 5. Step 2, Alice and Bob agree on a primitive root of their prime number. Let us test if the number 3 is a primitive root of 5. So g of positive whole number less than or p. So 3 raised to 1 is equals to 3, 3 raised to 2 is equals to 9, 3 raised to 3, 27, 3 raised to 4, 81. Then we set our upper limit of our output to the value of our prime by getting the remainder after the division. 3 mod 5 is 3, 9 mod 5 is 4, 27 mod 5 is 2, 81 mod 5 is 1. So now that we have found a primitive root, we will note its value g is equals to 3. So Alice chooses a positive whole number as our secret key is a is equals to 6. Alice computes her public key and sends it to Bob. A is equals to g raised to a mod p, or a is equals to 3 raised to 6 mod 5. So here we got, on putting these values, a is equals to 4. Step 5. Bob chooses a positive key whole number as his secret key, b is equals to 7. Step 6. Bob computes his public key and sends it to Alice. B is equals to g raised to b mod p, b is equals to 3 raised to 7 mod 5, b is equals to 2. Alice and Bob now compute a shared secret key. Shared key is equals to other person's public key raised to their own secret key mod p. Bob S is equals to 4 raised to 7 mod 5. Alice S is equals to 2 raised to 6 mod 5. So here we got S is equals to 4 in both the cases. So here we have a private key from the sender 5, and on the receiver side we have 4. So on the sender side we did 6 raised to 5 mod 13. We got 7776 mod 13. So we got our public key here 2. On the sender side we did 6 raised to 4, as 4 was our private key, mod 13. We got 6 raised to 4 as 1296 mod 13. So we got our public key here is 9. Agree upon two numbers. So P is prime number. So we have our prime number as 13 and G is generator of P. So we have our generator of P is 6. Randomly generate a private key. Calculate private key. G raised to private mod P, as we have already seen our steps, and then we need to exchange public keys. On exchanging our public key from receiver side 9 to the sender, and from sender public key 2 to the receiver, we have here is 9 raised to 5 mod 13. We got 9 raised to 5 as 59049 mod 13, and our shared secret key becomes 3. And on the receiver side we got our public key as 2. So we have here is 2 raised to 4 mod 13. 2 raised to 4 is 6 mod 13. Shared secret key here we got is 3. So we calculated this shared key by calculate the shared public key raised to private key mod P. This is the formula for it. Let's see what are the advantages and disadvantages of this encryption type. Advantages we have here are: the sender and the receiver have no prior knowledge of each other. Communication can take place through an insecure channel. Sharing a secret key is safe. Disadvantages are a problem with asymmetric encryption, however, is that it is slower than symmetric encryption. It requires far more processing power to both encrypt and decrypt the content to the message. I hope you understood the technique. Thank you for watching the video. For any query, comment on the video. Please subscribe to my YouTube channel for computer science subjects and insights IAS daily current affairs for UPSC 2021 preparation. Have a nice day. Bye.